Right, today's video is to show you how to make your own toolkit, as you saw being used in the previous episode where the mine was created. So if I drag across the toolkit that you may have used, this function called create mine does all that stuff. So if you watched the video and saw all the complex movements that the turtle was making, you might be surprised to see that it only occupies a relatively small number of lines. And the reason for that is, if you take one of these lines here, I'll just increase the size of the font a little bit so we can see what's going on. You've got this rather odd command here. So you've got T : go, and then a list of numbers and letters and kind of, well, what's that all about? This is the secret of having several thousand lines of code just compressed down to here, because what I've done is to create an object called T, which is short for turtle, and built my own methods and properties inside there to do all this kind of stuff. So that's what we're going to do today, is to show you how I can build your own toolkit. I won't frighten you by showing you the Go function up here at this stage, but you can download this and look at for yourself. So what we're going to do is kind of move away from Minecraft for a second and go into something a bit more simple. What if we wanted to create our own adventure game? So text-based adventure, you can do this in Python or any other language, and the very, very simplest of text-based adventure games may be where you want to create a player and then give that player a name and health, print out the statistics, and then carry on with building up your game. So let me just show you how this one actually works. It's very simple. Just drag this out the way. Oops, wrong one. Yeah, so I've written this one as adventure linear. You'll see why in a minute. Let's press enter. So what is your player's name? Let's type Fred. Enter. What's your player's health? Let's type 100. Enter. Fred has 100 health. That's great, it works. Now what if we redo that one, and then what is your player's name, and I just press the enter key. What's your player's health, and I just press the enter key. Player blank has health blank. Not terribly useful. So let's get that back out of the way, and we'll go back to this. So in our very simple linear game, if the player doesn't put in what they're supposed to put in, then it all kind of messes up and you don't get anywhere. So also, if let's say we wanted now to have another player, we'd then have to kind of copy all this. Even if you decided your second player was not, you don't want to get the input from the user, that you just wanted to create another player, you could say player 2 name equals player, and then you could set up some player health. For example, if we took that, control copy, control V, and we're going to say player 2 health equals 50, and so on. You can see that to make an adventure game that has got maybe some monsters in it, items, various rooms that you want to go into, you're going to have hundreds and hundreds of local variables plastered all over the place, and it all gets a bit impossible to do. So ideally what we'd really need is some kind of super variable that could hold everything we needed to know about our player, its health, the name, all the stuff it can do. That would be brilliant, some kind of super variable. Well, luckily there is such a thing, and this is where we come into object-oriented programming. So let's look at what I've done to make a slightly more complex adventure game here. Now you'll see, first of all, we've done it the proper way. We've got a main function, we've got a function main, which ends here, and all the stuff is inside it. So that's already looking a little bit more professional. So again, we've got create a player with a name and some health. So exactly as we did in the first one, we're using the same kind of input here. What's your player's name? You read it in. What's your player's health? Read it in. Now this is where it starts to get interesting. We've got this require here, which if you remember on the previous coding video, which was I think a couple of episodes ago, we used the require there to get in a pre-written library, and this time I've actually put it in a different folder, which I'll show you here. So this is my game save. So this is computer number 8, which is the one that I'm currently using. You'll see all the other files I've already created. You'll see some of them you'll recognize, the forward and the back and so on. And then I created a new folder in here called lib, and inside the library there's some more files inside there, including the menu.lua, which we showed you a couple of episodes ago, so that you can use the menu. But this time I've put it in a different folder called library. One of the reasons for doing that is that when you go back to the game, if I can just get this out of the way so we can go back to the game, let's slide that back up here. Okay, and then we clear that and list it. You can see we've got already quite a lot of files in here, and so it starts to get a little bit more. It's even asking us to press any key to continue the listing. But we've got one up here called lib, and that's the folder library, and of course inside that are more files. But you don't want to be using those library files directly. Those are there for use within the Lua programs that you're running here. So that's why it's nice to have, especially in Minecraft, to have a separate folder to put all your stuff in. So let's just go back to here. So I've now got this library folder, and I'm asking it to load in a file called class character. So again, if I show you where that is, so inside the library character we've got class character.lua. So that's the one that we want to load in. So let's go back to this line here. So we're now saying local player equals require this class character library. Then it's got .new player name and player health. So this looks a bit kind of complicated. So we'll come back to that in a moment, and we'll just show you how it works. So if I get that out of the way, and we go back to here, let's just get all that lot off. So we're going to clear that one. Right, so this one is called just Adventure. So if I hit it, what's your player's name? Again, I can type in Fred. What's your player's health? Let's type in 100. And Fred has 100 health. Great. Let's just do that one again. Adventure. But this time I'm not going to type anything in. I'm just going to hit the enter key. So I'm not entering anything whatsoever. Same with this one. What's your player's health? I'm not typing anything in. Just hit the enter key. Player has 100 health. Aha. So this time it's kind of worked. It's been idiot proofed, so that the programmer or the user who is trying to wreck the place doesn't succeed, which, as you know, is something I like to do. So let's get that back up and we'll see how that works. So let's go to the character file. Now this looks a bit complicated, and if you're not used to any kind of object-oriented programming, it is, but don't fret too much. Basically what happens is that we're creating a table here called class, which is CLS, which is short for class character. So this is my character class, and then at the end of it I'm returning that table. So in the same way as when we were using the menu item, we're returning a whole bunch of stuff that's in a different file. So that's the same kind of principle. The difference here is that we've got all this here, which is creating, if you like, what I was asking us for is this kind of super variable. So that this is the class constructor, which sets everything up so that we can then store within this table all the information we want about our player. It can have the name, age, health, hit points, weapon, whatever you want to do. It can all be stored in here. So just to give you a rough idea of how this works is that when we set this this new function up here, which is what we did from here, if I go back to this one, so we're doing the .new, and then we're giving it the player name, which we got from reading it here, plus the player health, which we also got from reading it here. So we've already got a name and health from reading it in. But if you remember, I deliberately tried to trash it by just pressing the enter key. So what we would have had in that case, instead of having a real name and a real health, we would have had just an empty string. So we pass those pieces of information here to our class character. So if we go back to that, so that in this one here where it says class character.new, we would have passed in this case, empty string, and in this case, empty string. Ignore all this stuff here, but when you get to here, if the name equals nil, in other words, we didn't even bother to pass anything in, or if the name equals empty string, then the name is set up to the default player. Same with the health. If we passed in health and we put and we didn't even bother to pass it in, that would be nil. If we just hit the enter key, then that would be an empty string. So we're saying if the health is an empty string, or health equals nil, then we'll give it the default health equals 100. So once we've done that, the self thing is used in Python. If you've done any classes in Python, it's the same in Lua. You use this self name here to store variables internally inside the class. So these are all stored for anything to be using. As you can see where it's all highlighted in green, it's used throughout the entire class. So we've now got self.health equals the health that we passed here, and self.name is the name we passed here, corrected if necessary if they weren't correctly given. So we really have completely idiot-proofed this constructor. So now health will either have the amount we passed to it, say 20 or minus 10 or whatever you wanted to pass to it, or by default 100. And the same with the name, it'll either be the name you passed in or it'll be the default player. So we're now got that all set up. Now I have in this case made a completely new variable called start health equals self.health. So if we passed in 100, then the health that we start off with is what we passed in. Now of course this can be used so that if in your adventure game you have fights with enemies or whatever, then the health can be reduced, but you'll always know what you started with, which might be useful later on. And then the whole self thing is returned back to here and then eventually back to here. So this is the kind of way I know this is complicated, but don't fret too much about the mechanics of it. What it basically means is you're creating a super variable that stores everything within it. Now the great advantage of that is that in our adventure game here we've already tested this out. So we printed, we got a player which I hit the enter key in, and it printed out the default player and the default 100 health. Now say we now wanted to have a second player. Instead of having to do a whole bunch of variables that we were suggesting down here, what we can do instead is just to do this. We'll copy that. paste it down, and now we're going to choose a different one. So we can call this one player2 equals that, and then we're going to give it a default name. Let's call it zombie, and let's call it 200. So we've now got a new player which has got the name zombie and 200 health, and again we can copy that to find out what our new created name is. So we'll call that player 2 health. Right, let's save that, and we'll go back to here, we'll clear that, and we'll go adventure. Again, ask the player's name. I use Fred because it's just 4 keys on the keyboard. Player's health, let's say 20. There we are. Fred has 20 health and zombie has 200 health. So in one line of code we have now created 2 characters, player and player 2. And so of course it doesn't end there. We can add as many what they call attributes, which is at the moment we've got health. I added starting health. We could add maybe the weapon that it's carrying, and all kinds of things. And then you can change, once you've created your object using this bit here, you can change some of the things in it by using what's called getters and setters. Now this one here gets the name of our character, so it was passed in here. We checked to see whether it was empty or not. If it was called player, otherwise it's whatever you sent it, and this function will return the name here, which is of course exactly how this works down here. I've got player get name. Now you'll notice that I've got a colon here. That's very important. The only other way of doing this is to use the dot function, which you may be familiar with, but you then have to put the word player back in there, which works, but it's easy to forget. So Lua has this nice convenient way of just, instead of having to send the function, send the object that you're using back to itself, you just put a colon in. So don't worry too much about how this all works, just know that it does, and once you've got your class set up and running, you've got a massive amount of stuff that you can do with it. So that's just to kind of give you the basis of how classes and objects work. So this is our class, this is what creates our character, and this is an object which is created from our class, and this is a second object created from the same class. Each of these two, player and player 2, has their own local internal variables, name, health, whatever. And of course what you can do is in the class itself, at the moment we've only set up name and health. We can actually run entire methods, as they're called, which is functions that actually work inside here. So we could, for example, if I do a function, let's say print details, and then don't forget the self. Now one thing that has to be done in this function, because it's inside a class, you have to preset it with this the class name. So we copy that, Control V, dot. So we've got class character print details self. Don't forget the self, because you're inheriting all this stuff from here, so you do need to do that. And what you can do in here is you can actually print out directly from within here the, for example, the health. So the print details is let's say your name is ... self ... name ... and your, if we can get the health there, or your health is ... self ... health. Right, so what we're doing here is we're actually, within the function itself, we're printing out your name is self name and your health is self health. So we're printing out all the stuff that we were originally getting from here. So what I can do for the second one is I could, instead of typing that that line as you see it here, I could just go player2 : and then print, was it print details? I forgot what I put in now. I think it was print details. Let's just check what I called it. Yeah, I did, print details. Excuse me, the lowercase p there, make sure I've got that. Yes, I have. Oh, I've missed out print details. So what we'll do is we'll hyphen off that one so that it doesn't run. And if I've got this correct, we should be able to print out the details the same as we did here, but using a function within our class. So let's save everything, get this out the way, let's clear this and try again. If I haven't made a mistake, then we should be alright. Adventure, oops, no, adventure, what's your player's name? Fred. What's your player's health? 20. Fred has 20 health, your name is Zombie and your health is 200. There we are, it's worked. So if I bring that back on, we've actually used the built-in method inside our class to print out that. So that shows you how powerful object-oriented programming is. We can now go back to this, and the same with this one. I can now get rid of that and copy this, Control C, Control V, just change that from player 2 to player, and that will work. So we'll save that, back to here, clear, adventure, what's your player's name? I'm just going to hit the enter key, there we are. Your name is player and your health is 100. Your name is Zombie and your health is 200. So that's an introduction to object-oriented programming, and now from the next video we can actually start to make our own turtle class, turtle object, and your own toolkit.